have some fun with Kubernetes security. So this is going to be a long session. We got 90 minutes. We're going to take about a 5-10 minute break, depending on what our pace looks like. I broke it up into 2 parts. If you have questions, I will make sure before we move through different pieces, you get a chance to ask them. I'm not going to make you wait 90 minutes to ask your questions. So who am I? My name is Marc Boorshtein. I am the CTO of Tremolo Security. I've been doing identity management for over 20 years. I've been involved in open source for that time as well. I got started in Kubernetes in 2015. So when RBAC got added in 1.3, OIDC got added, and I think 1.3 as well. I wrote a lot of rewrote a lot of the OIDC documentation because I was learning it at the time. And I also have donated the code to support impersonation for the Kubernetes dashboard, as well as Kiali proxy. Done some work on the Java SDK, so I'm a little all over the place. But I've been part of this community since 2015. Co-author of Kubernetes and Enterprise Guide, 2nd edition. I think we're actually going to be doing a book signing and a giveaway after this, so yay. Agenda, we are going to cover a lot. If you don't retain everything, then, yeah, pretty much. There's going to be a lot to go through. You will not be able to pass your CKS by the time you're done with this. But you should know what questions to ask, what to think about when you start going through these things. So the first part we're going to go through is what you should look at when you lock down your cluster. We're going to talk a little bit about what the surfaces are that you need to protect. We're going to spend a lot of time on identity. That's one of the things that's really unique about Kubernetes. And one of the reasons why I think it's been so successful is so much of its security is built around this concept of identity, identifying who's accessing the system, identifying workloads, making sure workloads have unique identities. Then we'll get into dashboards. That's one that comes up a lot. A lot of times I'll go into a company and they'll say, oh, get rid of the dashboard, it's insecure. It is not insecure, and we're going to talk about why. And then we'll get into network policies, so your classic firewall rules. We'll talk about node security, defense in depth, and multi-tenancy. So we're going to talk about a lot of stuff here in part 1. Part 2, we're going to talk more about container and application security. What to think about when you're deploying an application onto Kubernetes. Why your application is probably going to be where the problem is from a security standpoint, and how to address that. Basics of building a secure image. SBOMs, I'm going to throw as many buzzwords at you as I can over the course of 90 minutes, and then we'll have a test at the end. And then we'll talk about, kind of what a lot of people are talking about today in this concept of farm-to-table supply chain security, being able to track from build to runtime what's going on. So first off, what is Kubernetes? So from a 150,000 foot perspective, the 3 big components that we talk about a lot are going to be your scheduler. So this is the thing that figures out where your pod should go. Kubelet, so this is the thing that runs on your node, translates what's going on inside of your etcd database, your central database for all your configuration, into stuff on Linux. Everything I'm going to talk about is Linux. I'm not going to really get into Windows containers at all, because that is a completely other animal, and I honestly don't run into it a lot, so I don't have a ton of experience there. So we're going to focus on Linux. One joke is that 99% of what the kubelet does is it works with IP tables to change firewall rules. And then finally, the API server. This is the thing that you as a cluster operator, or even you as a developer, are going to be interacting with the most. This is your entrance into the Kubernetes world. Now, one of the things that makes Kubernetes so much harder from a security standpoint than other enterprise systems is that there's no UI, there's no app, there's no interface. Like it's just this base layer, and then you've got to build your stuff on top of that to build a platform. Kelsey Hightower very famously said Kubernetes is a platform for building platforms. So whether you're talking about Rancher, you're talking about kubeadm, you're talking about EKS or any of the cloud managed ones, there's all other stuff that has to go into it. And so that base layer where all those things kind of combine is at the API server. So that's where we're going to be spending most of our time in this conversation. So how users access the cluster. The first thing that people really have a hard time with is the fact that there are no users or groups in the cluster. Again, if you're thinking about Windows or even Linux, there's this idea that you have this database, whether it's a directory, Active Directory, whatnot, where there are users with a password and there are groups. That does not exist in Kubernetes. Now, somebody might say, what about service accounts? Service accounts are not users. Service accounts are credentials, and we'll talk a little bit about the difference there. But when it comes to figuring out how to do users and groups and who's accessing your API server, you have to first conceptualize the fact that there is no object called a user. So like when you look at an RBAC binding, that RBAC binding will say, what's your user or what's your group? But that doesn't reference an actual object that exists inside of your configuration database. So that provides some unique opportunities and some unique challenges. From an opportunity standpoint, it means that it makes it very easy to externalize your access management, which is the best way to go. Because there are a lot of drawbacks to trying to do all of your security inside of your API server. The challenge of that is that now you've got this extra component that exists outside of Kubernetes that you need to rely on for your security. And so like a common conversation I'll get into is, well, why can't Kubernetes just have its own users and groups? Well, think about it for a second. You create a user object, that's not a big deal. Well, that user object has to have a credential. Password, okay. How does the user set the password? Well, you don't want to have an admin set the password for the user because now the admin knows the password. That's not going to work very well. So now you have to have some kind of interface that the user can interact with. But how do you trust the user initially? Well, maybe you tie it to their email address the way most online systems do. That means your cluster now has to have a way to communicate with someone via email. And it just keeps going and going. So personally, I think it was a really smart move by the Kubernetes original developers not to try and embed users and groups directly into your cluster. So if there are no users and groups, how do you get a user and group into Kubernetes? You can reference it in RBAC, but they don't exist. So that happens at authentication, and it really depends on how you authenticate. We'll go through each of these. These are the most common ones you run into, certificates. First time you fire up cluster, usually you get a certificate. OpenID Connect, this is the one I'll always point people to because it gives you the most scalability from a network design perspective. And you can set it up to be as secure as almost any certificate implementation you're going to find. Impersonating proxy is really popular, especially when you are talking about cloud-managed instances of Kubernetes where you can't configure OpenID Connect. And then we'll talk about the token request API and why you should never write a custom authentication webhook. So let's start with certificates. Break glass authentication. So a certificate is good for Kubernetes when you can't access anything else. So it's the first thing, bootstrapped. A lot of on-prem, they'll hand you a certificate. A lot of managed ones, they'll hand you a certificate as well. Now, when I say that this is not a good way to go because it's not really all that secure, I want to make sure to caveat why that is. When you do certificate authentication correctly, it's the most secure way you can do things. But correctly means you generate a public key and a private key on a hardware, some kind of hardware key module. Based on that public key, you generate what's called a certificate signing request, which just has some information about your public key. And you hand it off to a CA. The CA signs it and gives you back the certificate. And now you can use that certificate as part of your authentication, as part of your TLS handshake. What makes it secure is the fact that the key never leaves your device. The secret material never goes over the wire. The problem with the Kubernetes implementation of TLS is, one, there's no revocation. So if your certificate were to, or really the key that goes with your certificate, when we say certificate authentication, were to be lost, you email it to the wrong person, you put it on the wrong thumb drive, you check it into the wrong account, or you check it into a Git repo by accident, It can't be revoked. Like, there is a way to revoke certificates. There are different technologies to do that. Kubernetes doesn't recognize that. That's been an audit finding for several years, and it's likely never to actually happen because there are a lot of issues around doing certificate revocation that the developers just, they don't want to deal with. And because it can't be revoked, that means that if you lose that certificate, the only way to make sure that certificate doesn't get abused is to rekey your entire cluster. Another issue is you can't use hardware certificates. So this isn't a limitation in Kubernetes itself, but in the implementation of the ClientGo SDK. The ClientGo SDK does not know how to do PKCS 11, which is the protocol that you use if you're going to read off of a hardware module. So something like a smart card, as an example. And you can't do an external CA. So what I mean by that is if anybody has ever done work with like the US federal government, everybody in the US federal government gets a PIV card, which is a smart card, has a certificate on it. Would be great if I could use that certificate with interacting with the API server. Problem is that means that Kubernetes needs to know to go trust the federal bridge, which it will never do. You know, every cluster has its own internal CA. That's the only CA it's ever going to recognize. So, yeah. And then groups are only supported through subject static mappings, which means that if you put a group into your certificate, and I'll show you what that looks like, and your role changes, that certificate is good until the certificate expires. So again, you've got no way to make a change at that point. And then finally, this is a big one. It requires a point-to-point configuration or point-to-point connection. When you do TLS authentication, you need to be talking directly to that server. So you cannot have any TLS termination endpoints between you and your API server, which makes segmentation kind of difficult. So there's a real impact there on scalability. So what does all of this look like? So I've got here can you see that? Yeah. So what I'm going to do here is I've got my let me, yeah, okay, cool. Okay, we can see that, cool. So I'm logging into my demo cluster. It's running on Azure Kubernetes Service. And I go ahead and I do get nodes. And the interesting thing about AKS is they actually give you a certificate. So I'm going to go ahead and decode that certificate. So what's going on here is YQ is a utility for working with YAML. I'm going to grab my Kubernetes config, pipe it into JQ. So YQ is going to translate it into JSON. JQ is going to let me parse it. And I'm going to get the client certificate out of that configuration, pipe it into base 64, and get a bunch of information about it. And what I want to show you here first is this is our validity. This certificate is good until 2025. Now, this cluster is not going to last until tomorrow, but the fact is if this was a long-lived cluster and I lost this key, nothing I can do about it. Hope, pray, if that's just, your thing. So that's the first problem. Second problem, let's take a look at the subject. This is the really important part here, this O equals system.master. So you can, in a certificate, you can tell Kubernetes what groups you're a member of by adding O equals to your subject. This is called a distinguished name. Now, system.masters is particularly problematic because this doesn't mean I have access to do everything. This means I'm just going to bypass the access controls entirely. So RBAC never even runs. So you've got auditability issues, you've got tracking issues, you've got all sorts of problems. This is why you do not want to be using certificates for your day-to-day work with Kubernetes. It's just, I probably see in the Kubernetes Slack, every couple of months, hey, what happens if I lose my master certificate? And the answer is go rekey your entire cluster. So when you're doing Kubernetes, you get that master certificate, you get that bootstrap certificate, that's the first thing that gets created. You put that in a vault somewhere and you never use it again unless external authentication doesn't work. All right, so next up is OpenID Connect. This is what you want to be using most of the time. Use of a JSON web token. These are bearer tokens. So this is a trade-off in the security world. The token goes over the wire, which means anything that holds that token is a potential place that could lose that token. And it happens all the time. CNIs, your networking implementations, developers log it by accident. People forget to use HTTPS and they lose it to wire snoopers. It gets persisted. LastPass breach, we'll talk about that. People get these long-lived certificate or long-lived tokens and they check it into source control. A million ways you could lose it. And so you gotta be careful about that. We'll show what that looks like. But the great thing about it is it gives you more flexibility. So easily map groups. You can keep it short-lived, so that's your main mitigation. There have been attempts to write standards that will bind a token to a TLS connection. They've never gotten much traction because they're just not really flexible. And you lose a lot of the power of the JWT. But this also lets you do segmentation. So you can have reverse proxies and intrusion detection systems and whatever between your developer and your Kubernetes cluster because it just goes over the wire. So let's see what that looks like. Oh, and you can't revoke it. That's the other thing. So you can't say, once a token gets minted, you can't say, I'm not going to trust that token anymore. Kubernetes doesn't know how to do that either. So it's really important that you have short-lived tokens. So what I'm going to do here is, let's go ahead and log in. So I'm going to log into the OpenUnison instance that I have protecting this cluster. Yeah, stay signed in, sure. Now, I'm integrated with Azure AD, depending on what, Okta, LDAP, whatever, but have something that you're integrating with. So let's take a look at our tokens, and I'm going to pull out an ID token right now. Now, there's this nifty website called jwt.io, and I'm going to tell you never to do what I'm about to do. So because this is a bearer token, now this site from a company called Autho knows what they're doing, but in theory, I just pasted in the key to my castle into this website. Now, this isn't phoning home, this is all local, and I really don't care, this is a development cluster. But what I want to show you here is kind of the basic components. So this issuer says who created this certificate, or excuse me, JWT, where it's going, the sub, who it's for. Now, I'm using a user principal name here. This is actually a big anti-pattern. Most examples you'll see are user principal names or email addresses. You don't want to use those because Matt Mosley over here might change his name for a lot of different reasons. Now, if that name changes and you've got controls or you've got RBAC that's tied to that name, you got to go back and change it. So you really want to use something that is immutable. It's never going to change. So that way, if the name does change for whatever reason, you don't have to go and change your security. And then the other thing here that's super important, groups. I'm a K8s administrator. Now, for the life of this JWT, I will be a K8s administrator, but the thing is the next time I'm into JWT and I'm not a K8s administrator anymore, I don't have access to as an administrator. The other important part here is there's an expiration. So I know it's a little hard to see, but this is going to expire at 1400 hours UTC. So it's already expired. It expired a minute ago. So if this expires so quickly, how do I keep working? Well, OpenID Connect, you get a refresh token. The refresh token sits on your device, your laptop, your workstation, and is used between you and the identity provider. So that never goes to Kubernetes. That never goes over the wire. Whatever APIs you call never sees it. It's also one-time use only. So once you use it, It's like Mission Impossible. It burns. You can never use it again. So that's where the trade-off comes between certificates and OpenID Connect. So the next question becomes, you can use OpenID Connect when you're talking about on-prem clusters. But what about your cloud-managed clusters? Now, your first thinking might be, well, I'm just going to use my Cloud IAM. Cloud IAM with AKS was a certificate that we said was bad, right? EKS is a little bit different, where they actually integrate pretty well with AWS IAM. But then it becomes a question of, do you really want your cloud team to be responsible for authentication? And what often will happen is the cloud teams will say, no, we don't want that responsibility. We have enough work to do. And so impersonating proxies become really popular. The concept here is that you can take a reverse proxy. Now I'm showing this off of the dashboard because I got lazy when I grabbed my graphics. But you have a reverse proxy that will authenticate you. Once it authenticates you, it then adds these headers into the request. Those headers are actually who you will log in as. So when it sends the request, so I say, okay, give me nodes. The identity that gets sent to the API server is the identity of my reverse proxy. It's the service account of my reverse proxy. But the work that gets done is as the impersonated user. So when you look at the logs, when you look at your access logs, it's going to say, Matt Mosley was, this action was done by this reverse proxy impersonating Matt Mosley. So you know, one, it was an impersonation, and two, who was being impersonated. Now, anybody who's spent any time with security, this is probably throwing up all kinds of red flags and alarms of danger, and you're 100% right. There are a handful of projects that do this. At Tremolo, we forked a project called Kubo IDC Proxy that we continue to maintain. The Pinniped project from VMware Tanzu does this pretty well. Those are the two main ones I can think about. I think Rancher does this internally, but don't quote me on that one, I might be wrong. This is very hard to do. Do not try and write your own bespoke impersonating proxy, because you're probably going to do it wrong. It's kind of like writing your own encryption. But you do it, when you do it right and use a project that knows what it's doing, it becomes incredibly flexible, because now you can authenticate on the front side however you want and still be able to interact with the API server. So it doesn't matter if you're working with a cloud hosted or an on-prem. So I'm going to come back here, and let's go ahead and go over here. RM kube config kget nodes, right? So can't get anything. Clear. All right, so what I'm going to do is, first I'm going to show you what it looks like going direct. So this is the context where I have a certificate. And what I'm going to point out here, this is the important bit here. This is an AKS URL. So I'm going directly to my API server. Now, if I come here, oops, wrong one. And I'm going to come back over here. So I'm going to use OpenUnison to log in and SSON. All right, so I'm now logged in. I'm going to run that same knodes v6. There we go. So it took a second. And here's the important bit. We're now hitting the Kubo IDC proxy that's running inside my cluster. So the token that OpenUnison gave me gets sent to this Kubo IDC proxy. That token gets validated, and then the Kubo IDC proxy injects the right headers. So that's how Kubernetes knows who I am and what I can do. Oops. That's why. Okay. Go back to slideshow. Token request API. So we've talked a lot about how users integrate with the API server. The next big thing to really talk about is how pipelines are going to do it. And we'll get a little bit into that more, but the old way pipelines would do it is service account would get generated. That service account would have a token. The problem with that token was it never expired. So it was a little similar to certificates in that if you lost the token, anybody could use it. Now the big difference between certificates and tokens is you could delete the secret that the token was in, recreate it, and now the API server wouldn't accept it anymore. Starting in 1.24, there was a move towards this token request API, where the idea was that when a secret or a pod launched, it would get a unique identity, not just for the service account that it ran under, but the pod itself would get a unique identity, and that identity would have an expiration on it. So not only could the token only be used for a certain amount of time, but when the pod goes away, that token would no longer work. So like, I think it was Rancher was pulling service accounts out of pods to provision to users, I think. And with 24, they couldn't do that anymore because once the pod died, you can no longer use that service account. And I'm not picking on Rancher, I'm just using examples of what people did. So kind of show you what that looks like. All right, I gotta get the token here. So what I did here, kubectl exec ti. So I'm basically saying I want to execute a command inside of my OpenUnison pod. Then I'm going to get my var run secrets token, OU token. So this is a projected token. That's what the token request API does. So I will once again do what I told you not to do. Copy and paste this into jwt.io. So this is going to look a little bit different than what you saw from the user. It has an expiration. It has an identity. And this UID is actually the UID of the pod. So that's how you know which workload this identity is associated with. Now what's really important about the token request API is that it was originally intended, I don't know why this isn't going back, weird. It was originally intended for identifying workloads to either the API server or a third-party system. So kind of the classic one is Vault. You can take that API, you can generate a token where the audience is not the API server but a vault. HashiCorp Vault as an example, that will authenticate the request to pull in secret data without having to have a shared secret. And without Vault having to do a subject access review to check whether or not that token's good, because all the information that you need is in the token to identify the workload. But it is not designed to let you use that token from outside the cluster to talk to the API server. And we're going to talk about that one next. Custom webhooks, just don't do it. Just don't. They either are poor imitations of OpenID Connect or they are pass the password. If you're a cloud provider and you have your own custom IAM, that's a little bit of a different story. You probably have lots and lots of engineers who understand that forward and back. But if you ever are deploying a Kubernetes cluster in an IT environment and you think I want to do a custom webhook for authentication, just stop what you're doing and don't do it. So we spent a lot of time on authentication. Any questions? I will always recommend OpenID Connect or OpenID Connect plus impersonation. Now, I will say that there are, full disclosure, my company builds an OpenID Connect identity provider, right? There are projects that do a pretty damn good job of managing certificates. Pinniped from VMware does a really impressive job where their certificates are like 5 minutes that they mint. They do some weird stuff with certificates that I'm not really thrilled with, the way that they handle it, but they're a very opinionated, API-focused approach. But otherwise, tokens are the way to go. Yes?
I'm thinking about how this bootstrapping occurs with the OIDC provider and the cluster itself. Common sense would seem to dictate that the OIDC provider is not running inside of the cluster that it's providing identity for. So
Not necessarily.
have you seen that work well, or is
Yeah.
it much of a problem? It seems to me like if something goes wrong, then there's no recourse. Really.
Well, you still have break glass. So you deploy your identity provider into your cluster. I like to deploy my identity provider into the cluster. I think that because of the way that cluster management applications work, the way that people tend to manage their clusters, you want to keep it inside of the identity provider, inside of the cluster itself. And then you're using it as much as possible. And then if it does break, because things break, it's IT, right? That's why you have the break glass scenario. So you have, typically what you'll have is you'll have a workstation that has that certificate on it or can get access to it, or you check it into a vault that you can use a privileged access control system with. But yeah, it's fine running it inside the cluster. Any other questions before I hit? Yes?
It sounds like very chatty with the identity provider. Do we need to plan something like scaling identity providers for, to handle that load?
Sorry, what was the,
Do we need to scale identity providers?
oh yeah. I mean, and scaling is kind of relative. The largest clusters that I've seen might only have 1,000 people interacting with it, which from an authentication system is nothing. Like that shouldn't, any authentication system out there, that's no load at all. That said, you want to have high availability. You want to, like what I typically do is I find that clusters will typically have 1 or 2 nodes that are dedicated to control plane tools, management tools. Stuff that is for managing the cluster. And so you'll want to make sure that your identity provider is bound to those if you have that available. But yeah, from a scalability perspective, you are not generally putting a huge load on those systems. Cool. So once we tell the cluster who you are, what can you do with that information? So role-based access control, RBAC, is how the API server, how you protect the API server, how the API authorizes who can do what. There are 2 levels. There's cluster-wide stuff and there's namespace stuff. Your namespaces are your security boundary, mostly. And I'll talk about that in a bit. The cluster level stuff is, if you think about a multi-tenant environment where you have multiple people running workloads onto a Kubernetes environment, it's cluster scoped if it's going to affect everybody. It's namespace scoped if it's only going to affect the workloads in a single namespace. So the namespace object itself is cluster scoped. That's the one that often gets people, because you will often write annotations for security inside of your namespace. So you don't want the person who owns the namespace to be able to make up their own security as they go. So that becomes a cluster operation. So there are 2 sets of objects that you're going to build. Roles and cluster roles. So that defines what the permission is, what you can do. Now what's really important about this is that you have to enumerate everything or allow everything. So what I say by that is you have to say, I'm going to let you do things to secrets and config maps, or I'm going to let you do things to all the objects in a namespace or in a cluster. What you cannot do is say everything except Secrets, that's one that comes up a lot. I want to write a policy that lets somebody do something, whatever they want in a namespace except read secrets. You cannot do that in RBAC. In Kubernetes, it's not allowed. And we'll talk about why in a second. Role bindings and cluster role bindings, once you've defined the permission, bindings is who can do it. You can cross the streams. So you can write a cluster role that can be defined to say, I'm going to write this cluster role that only applies to namespaced objects, but can be used by any service account across the environment. So like, I'm going to create a cluster role that says, I'm going to be able to edit config maps. And then you use a role binding, which sits inside the namespace, to apply that set of permissions inside a particular namespace. Or you can write a cluster role binding that applies it universally across all namespaces. So there's a lot of mixing and matching there. Like I said, rights are enumerated and there's no negative rights. This is really important because the way Kubernetes works, everything is an object, right? Everything you interact with is an object. So a popular pattern is to say, I'm going to do work with cloud resources by creating a Kubernetes object and then having an operator that watches that object for changes and does something using my cloud credentials. So I want to provision a database in my namespace as an example, but that namespace runs in Amazon, or I'm sorry, the database runs in Amazon. So I'm going to create an object that some other process reads and goes and creates the database out in AWS, an RDS database. Well, if you had negative roles where you said, I want to be able to do everything in the namespace except edit secrets, that now includes create databases. And you probably didn't intend to do that. So what you really want to do is you want to enumerate everything. Don't use stars. So Ian Coldwater, co-chair of SIG Security, they said, we are all made of stars, but your RBAC shouldn't be, and that's 100% correct. You don't actually want to use stars in RBAC because, again, same thing. You don't know what's going to come out in the future, so you want to enumerate everything, which kind of begs the question, how do you do that in a scalable way? And we'll talk about that next. And then finally, bindings. Groups, not users. So Kubernetes, most Kubernetes distributions are built on a database called etcd. Etcd, you can't just say, give me every user that's a member of XYZ role binding. It's not built that way. You have to enumerate every single role binding, which makes auditing painful. Whereas if you do it with groups, now you can go to your LDAP directory or your database or whatever and say, give me all the users that are a member of this group. It makes the auditing process so much easier. So we talked about having to enumerate everything. That creates a very difficult problem of how do you create a scalable way of managing large enumerations. So for instance, there is a pretty common RBAC binding that comes out of the box, or RBAC cluster role that comes out of the box called editor, or admin, excuse me. This lets you do anything in a namespace, but it's not written with stars. It's written using this concept of an aggregate role, where you can label a role or a cluster role to say this is an aggregate where anything that has this label gets integrated with it. And there's a controller that looks for any cluster role or role with that label and builds it out. So this way, you're deploying a new custom resource system. You've built the new widget that you're going to have a CR to represent that widget. You're going to have an operator that looks at that CR. But you want namespace admins to be able to create that. Well, instead of trying to edit the admin binding or create a new binding, you create a labeled binding and the controller will pull it in. So let's take a look at what that looks like. You're going to have to log in again. So I'm going to go to cluster roles, and let's look for admin. All the way to the bottom. So this hard to read, so let's make it bigger. So this here, this aggregation rule, this is what tells the API server, hey, any cluster role with this label on it, integrate it into this role, cluster role. So where you see all of these different permissions that got created, this was the controller that was looking for cluster roles with that label and integrated it. So if I add a new cluster role with that label, those permissions will automatically go in here. So that's how you manage that dynamic environment of being able to enumerate. Very powerful concept. And if you're looking for a job, this is a question that they will try to stump you with, because a lot of people ask this just to see if you know what it is. That was a very fast run through on RBAC, incredibly complicated topic. Any questions?
When you say groups, not users, you were referring to like sort of like using tags to apply an attribute to something as opposed to identifying a specific entity?
So the question was, are groups tags? No. I get where you're going with that, though. No, when I say groups, I mean if you think about Active Directory, if you're familiar with that at all, you have users and you have groups. You can put your users in those groups and then provide that access. So as an example, I'm going to come here to my logged in user. My logged in user is a member of the Kate's Administrator group. That's a group I created inside of Azure Active Directory. I then have a cluster role binding that says anyone who's a user of this Kate's Administrator group is now a member of the cluster or has access to the cluster admin cluster role. So by doing that, okay, Matt's time with this company is over, or his role has changed, or he just doesn't want to have credentials anymore, or he's a privileged user and the time is up for his change window. You remove the user from that group in your identity provider, and now you don't have that access across your cluster anymore. If you did that directly using a cluster role binding, addressing the user, you would have to go through every single cluster role binding and figure out where Matt had access. So you're externalizing your authorizations into your database or directory as opposed to trying to maintain them directly inside of your API server. Yes. That's one of the major downsides of service accounts is that you can't add a service account to an arbitrary group. There are some groups that they are members of, so like every namespace has a group associated with it for all of the service accounts in that namespace. I've seen people try and use that, and it's really hacky and really ugly. But yeah, you can't assign a service account to a group. That only comes from the outside. Any other RBAC questions? So we've talked a lot about users, pipelines. That's kind of the next thing that comes up. You have really common use case. I do a build. My build generates a container. I have a new tag. Now I have to patch a deployment or some other deployment system, because there's more than deployments these days, a stateful set, whatnot, to say what the new tag is. I need to talk to the API server to do it. And we're getting to the point where this looks a lot like a user, to be honest. Now, the reason I say that is you don't want to use long-lived tokens. So LastPass got hacked, and part of it was there were service account tokens that were in the Git repo that the person got access to, was able to get into the central repo. You don't want to have these long-lived tokens. They can't be revoked. They're difficult to manage. So what you want to do is you want to use a system that gives, excuse me, my allergies are catching up with me today. Most workflow systems have a way of providing you an identity. So GitHub does this, GitLab does this. There's also a really good system called Spire. The system is called Spire, the standard is called Spiffy. That'll generate tokens in a way that is agnostic of the system that's running it. And the great thing about these approaches, AWS does this as well, where you have this ephemeral identity that is tied to a specific workflow, and there's a way to validate it. I was hoping to have a demo set up for it. I didn't get there. But the best way I like to do this is with a impersonating proxy. So we talked about KubeOIDC proxy before. Well, KubeOIDC proxy can validate tokens. It doesn't matter if that token comes from a user or that token comes from a workload. All you have to know is what the public key is to validate it. So now you set that up in front of your API server. You set up RBAC rules to make sure that it's very constrained on how it can work. And you can use these short-lived tokens for interacting with your API server without having to have long-lived tokens. This is still very new. A lot of people aren't, we're just starting to see people do this. If you get plugged in at all with supply chain security conversations, this comes up a lot. We're going to talk about it a little bit when we get towards that. But don't be the empire. Don't let the older code work. Dashboards. I'm not going to spend too long on dashboards. 2018, I think, Tesla gets hacked. They have a dashboard with admin privileges in a cluster. Somebody gets into that cluster. They get into that dashboard. They get those privileges. They use those privileges to get cloud privileges and start firing up some crypto mines. And ever since then, the word has been you don't use dashboards. And that is a load of hooey. Dashboards are an integral piece to operations. I swear by them. I love them. You cannot get as much information visually from kube control that you can through a visual dashboard. And there are two types of dashboards. There's centralized dashboards, like the Kubernetes dashboard. You saw me using it before. We deploy it securely using impersonation. So we have an impersonating proxy in front of the dashboard. That dashboard, that impersonating proxy gets a token that we maintain inside of our front end, sends it down to the dashboard. The dashboard uses that to interact with the API server. So if you get into the dashboard, you get the dashboard's token, it has no rights. I mean, it's got some very basic rights, but it doesn't have admin rights. Everything's based on the user. So you can absolutely deploy it every bit as secure as your API server. There is a big trend towards local dashboards because, one, a lot of people don't know how to properly deploy a dashboard in our community. Two, we think it's more secure. I'm not really ready to say that it is, and here's why. Here's an example. I like Octant. Octant is a dashboard from VMware, and it works real well. I like it when I don't have my stuff ready to go, a dashboard ready to go. But the way all these dashboards work is basically the same way. They open up a port on loopback 127001. So you have to be on the local system to access it. But there's no security on there. There's no token, there's no identity. There's nothing you can do to secure that, right? So any process that's running on your system, even if it's not in your user context, can get access to that port. Is that as secure as a centralized dashboard where I could revoke a session? I don't know. I am not convinced that a local dashboard is any more secure than a centralized dashboard. Now, this runs off of my user context. So if I'm logged in with OIDC, I have that as a benefit. But you're still using this port forwarding. So you want to be careful about it. I'm not saying don't use it. I'm not saying that they're better or worse than centralized dashboards, but they're not the universal security tool that they're often described as. Any questions about dashboards? Okay, got a lot to go through. I know it's already 2:30. Network policies. So this is where we start to go into, if you're used to more classic network security, where you have to write firewall rules. So if you've ever used like AWS security groups, same idea. Now what's great about this is it's still identity based, where that you can bind things to specific namespaces, you can bind them even to specific pods based on labels. They're not on by default. It depends on what network implementation you use. So me, if I'm launching a local cluster, I don't need to do a lot. I like to go a flannel. That's like the most basic network infrastructure there is. They don't support any kind of network policies. This is using Calico. eBPF is everybody's favorite these days, it seems. That obviously supports it. So almost all of them do, but not all of them do. And they're not on by default. If you don't explicitly say, turn off inbound ingress or even turn off egress, you're not going to get any kind of controls in place. So let's kind of take a look at what that looks like. So I'm going to come back here. I'm going to come to my dashboard. Now, I have network policies for my Open Unison implementation where I only want you to be able to connect to my pods from the ingress controller. I don't want you coming in from another namespace, another pod in another namespace, being able to talk to my pods. So let's see what that looks like. So I'm going to go to Ingress Nginx, pods. So here's my controller. So now I'm inside my cluster. And where am I? And I want to talk to my impersonating proxy. So this curl command just goes and tries to hit the Kubo IDC proxy orchestra service inside the Open Unison namespace with the service suffix. And it comes up. Like, what comes back is not super important, other than to say I was able to talk to it. Now, I'm going to run the same command from a pod in my default namespace. And it's just going to sit there, because even though it can resolve DNS, the network policies are stopping it. So now, if there's somebody inside of my cluster, and maybe they should be, maybe they shouldn't be, they can't get to my identity system. So kind of going back to the question of should I run my authentication system inside the cluster, network policies is going to be a big important part of that. Questions on network policies. Now, I'm not showing you what they look like because I've got 90 minutes total, but this is what they do, and you'll know what to look for. Yeah.
I don't know much about it, but what is like Cilium's role in, with network policies and like enforcing?
So what is Cilium's role? So Cilium is a network provider. So everything in Kubernetes is a plugin, basically. Like there's a core, and then everything gets plugged in. So Cilium is a network provider built on top of eBPF. The network provider is what's actually responsible for enforcing those rules. So it interprets the API server configuration. So this way you don't have, like, if you're used to firewall rules defined in Cisco versus defined in Palo Alto, they all have their own different, versus IP tables, they all have their own different language. Network policies give you a common language for all of them. So secrets. This is another one that I could probably do like a 3-day course on. So we're going to keep it as basic as possible. Stored in etcd as base64 encoded strings. No, they're not encrypted. The reason why they're base64 encoded is because often passwords and secrets are binary. They're case sensitive. That's a big interview question. Anybody who is looking at interview, that's a big one that comes up a lot. That's a gotcha that they'll ask you. So it's base64 encoded in order to preserve any case issues. There is a lot of myth around how to properly manage a secret. most of this link here, this bit.ly, is to a great blog post called "The Plain Kubernetes Secrets Are Fine." And the thesis of the blog post is that storing your secrets in etcd is fine because if you actually go through the threat modeling, that's no worse than anything else. If you are going to use Vault to as secure as you can go, there's no more DevOpsing. So I think that's a verb, DevOpsing. Maybe I invented it. Or maybe somebody on Twitter will yell at me about it. But the point is that if you go as far as you can with Vault, you're going to lose any of the benefits that you have with Kubernetes and automation. And quite frankly, where you're most likely to get attacked is not through your secrets management system. That said, I'm a big proponent of externalizing your secrets. We haven't talked about a concept of GitOps, where you're externalizing your configuration into a Git repo, but never, ever, 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 ever store your secrets in Git. I don't care if they're encrypted. Never. Not in Git, not in Helm charts. And the reason is, even if you encrypt the secrets, talk about Git for a second. Git was specifically designed so that you could easily share repos that you cannot track. So Kelsey Hightower did a demo of Vault integration with Kubernetes a couple years ago, the SIG Auth team. And he said, and I'm paraphrasing here, he said something really smart. He said, using external secret management isn't about protecting the secret, it's about tracking it. It's about knowing who's using it. Well, if you store your encrypted secret inside of a Git repo and you lose that Git repo, say you download it from GitHub and then push it to GitLab, you're done. You can't track it anymore. It is now out of your hands. So putting your secrets in Git, bad idea. Oh, they're encrypted. Okay. We're really bad at managing keys. Like as a species, we're terrible at it. You create a key, we're going to lose it. Well, you're going to lose the code, you're going to lose the key. That's a really bad day. You got to rekey, right? You want to constantly rotate your keys. You don't want things to be static, right? Well, if you've got stuff encrypted across, a couple of dozen repos and now you want to rekey, that becomes difficult. You don't do it. So plain Kubernetes secrets are fine. It's still good to externalize them. You can integrate them with your pods in one of two ways. You can either mount them directly to a pod using a controller. So you say, hey, Vault, I want you to mount these secrets directly using something called a CSI, where it actually thinks it's storage. Or you can synchronize them into your etcd through a third-party process. External secret store is an example. Both are fine. Depends on your use case, but they're both going to get you where you want to go. Any question on secrets? Yep.
Do you mean are you meaning like the obvious, like we're not storing like ID tokens and all that stuff, things of that nature in the code, or do you mean like as like repository variables for like your pipeline?
So, okay, that's a good question. The question was, am I talking about storing ID tokens or really any credential? Right. Versus, in the code versus putting it in environment variable. So let's talk about like a password for database password, right? That's a real easy one that people often talk about. Well, I think everybody would agree you wouldn't want to store that password inside of your Python that gets stored in a Git, right? That's bad. So what a lot of folks will say is, but I will encrypt the configuration file that stores that password and put it in Git. And then I'll have something that knows how to decrypt that secret at runtime. That's what I'm talking about, where even if you've encrypted that password, you're storing it in Git, you're asking for problems. It's easier than Vault, at least on its face, but it doesn't scale. It doesn't work well, and it's great until bad things happen, and in security, the bad thing will always happen at some point. Does that answer? Okay. Any other questions on secrets? All right, how are we doing? We're running a little late. So node security. This is another big topic area. So we've talked about RBAC and how to protect the API server. When you're talking about Linux containers, there is no such thing as a container, right? It doesn't really exist. It's just a process that uses different Linux technologies, CNAMEs, C groups, namespaces, etc., to give it a little bit of isolation. But that isolation is paper thin, very easy to break through. So what you've got to do is you've got to figure out a way to make sure that a container can't run itself in a privileged way. That's how you protect your namespace. And that's where node security comes in. You know, the first one is you don't run your containers as root unless you absolutely positively 100% have to. And no, running a port less than 1024 is necessary, never necessary, and you should never be root to do it. Except for sometimes init containers, because a lot of cloud, especially cloud managed, Kubernetes distros will permission a mounted volume as root. So now if you've got a container that's going to run as non-root and a volume that's root, you need something to change the permissions on your container. So a lot of times you got to write an init container just to do a chmod that has to be root. And so it gets complicated. But you know, that's why we're here, right? This is done using an admission controller. So, you know, there are really two aspects of it, mutating webhooks and admission controllers. The mutating webhook lets you change something before the pod gets submitted. The admission controller lets you enforce it. So mutating webhooks is a great place to implement sane defaults. I'm running a cluster that's going to be running web applications. No one needs root, right? Nobody needs root for a web application. I don't care if it's a microservice or a monolith. You don't need root to run a web server unless there's some really specific reason. So you have a sane default. That way your developers don't have to know to write good code, or excuse me, they don't have to think of every security aspect in their YAML before they deploy. You're giving them a sane default. OpenShift never got enough credit for doing a really good job with this. So you implement that using your mutating webhook, and then you say, okay, if you are still trying to force something, I'm going to enforce it in the admission controller webhook. So common tools for doing this, pod security policies were eliminated in 1.25 because they were just too hard to manage. So they were replaced with pod security standards. I haven't done a lot with them. They make a good attempt because they're trying to kind of do that 80-20 rule, and they're probably good enough for most implementations. I've done a lot of implementations with OPA Gatekeeper, and I'll show this real quick. OPA was a tool originally written for just generic authorizations. Then Microsoft kind of put this gatekeeper wrapper around it because it wasn't Kubernetes native. So they're often referred to in the same space. Kyverno came out a few years ago. Nice thing about it is that is Kubernetes native. So whereas OPA is a generic authorization engine, Kyverno is Kubernetes native. So a lot of folks like that because they don't have to learn this third-party language. And then finally, Loft came out with this concept of JS policy where you're using JavaScript to implement policy. So if you're a JavaScript developer, that might be a good route to go. So what does this look like? So I'm going to go back to my OpenUnison implementation here. And I'm going to go to deployments. Am I in deployments? I might have timed out. Yeah. Yep. Oh, interesting. That's going to make life interesting. I've actually had this before, so I'm not going to be able to demo this. My forward proxy is probably, the forward proxy that I'm using, the Wi-Fi here, is probably not liking my certificate trying to rewrite it. I've seen that in the past during demos. Okay, so I'm not going to be able to demo that one. Any questions about node security? Again, I know it's kind of a lightning approach to it. So defense in depth. I've thrown a lot at you in the last hour hour and 30 minutes so far. The important thing is don't rely on any one single technology. You want to integrate all these things to approach security in your cluster. Strong identities, RBAC, policy enforcement, multi-factor authentication. I cannot stress this enough, how important multi-factor authentication is to any implementation. I shake my fist of rage at anybody who says that I don't need it because my cluster isn't exposed to the internet. Yes, you do. You need multi-factor authentication. Even something as simple and stupid as based on SMS or even email will stop drive-bys. And then you can get into debates around, whether push authentication or code-based or whatever. But even just the simplest of multi-factor authentication will stop so many attacks in their tracks. Use your short-lived tokens, and then self-service, this is a big one. The easier you make security, the more likely people will use it. You make it hard, they're not going to use it. So you integrate it into the process, you make it so that they don't have to think about it. So I want to get access to a cluster. I ask for access to the cluster, I get access to the cluster. I don't do the email shuffle. I want to create a namespace, I ask for that to get created, and it all just happens. It gets approved. I don't have to do anything, right? There's no kube control commands that get executed. That'll increase your security posture because now you've made it easier for developers to get what they want. They're not going to look for workarounds. Multi-tenancy. There is this vicious rumor in our community that Kubernetes is not built for multi-tenancy, and it works fine with multi-tenancy. It's not easy, don't get me wrong, but it does work. That's not to say you have one cluster for everything. You're going to have multiple clusters. But the idea that everybody gets their own cluster, you get massive sprawl. The idea that Kubernetes team, every application team is going to have Kubernetes experts. We're difficult to find, we're expensive. That's going to be difficult to scale. So what you want to do is and something has to be multi-tenant. Like if you're saying, okay, Kubernetes isn't multi-tenant, well, the thing that provisions your clusters is going to be multi-tenant. And so all you've done is move the multi-tenant problem to a different layer. Now maybe that layer handles things better. I don't know. But in my opinion, in my experience, and full disclosure, I sell stuff that does multi-tenancy in Kubernetes, so take it with a grain of salt. The idea of cluster per application, it doesn't scale. Most implementations I've seen that have said we're going to go that route will find that they can't handle it and they move towards multi-tenancy anyway. Really cool technology that I'm really starting to enjoy, this concept of virtual clusters, where you get your own private API server, your own CRDs, but you're running in the context of a larger implementation. So you're kind of getting the best of both worlds. Still in its infancy though. That project's only existed for about a year. Okay, so we've got about 30 minutes left. We're running a little bit late between our sound checks and just there's a lot of information here. So part 2 is talking about your applications and your containers. So chances are your biggest security risk is going to come from the stuff running on the cluster. Developers don't patch as often as we'd like. Log4j, right? I hope I just hit somebody's bingo card. So, the first question is if my application is the most dangerous thing running in my cluster, because that's what people have access to, should it be able to talk to the API server? And so the NSA came out with a hardening guide, and the first thing it says is if you don't need to talk to the API server, tell it not to mount the service account token. Now this is 100% accurate. I'm totally on board with it. But this is going to become less and less likely over the next few years. The Kubernetes API is going to become the data center API. I'm going to do a little futurizing. Futurizing, is that a word? Where, look, it's a simple API, it's being expanded upon. You've already got the cluster API that's used to provision other clusters. So this would have been a good meme of 3PO being like, machines, building machines. So, it's going in that direction. And so the idea of saying, well, I just won't let my apps integrate with the API server, that's not going to last very long. So what you want to do is you want to make sure that, one, you have same defaults. You're dropping all capabilities. You're not allowing privileges. You're locking that part down. And then you also want to make sure that your tokens are short-lived. So by default, Kubernetes tokens are, I want to say, an hour, maybe even a year. I'd have to double check. Like with Open Unison, we wrote our Helm charts to limit it down to the minimum of 10 minutes. I like 1 minute personally, but that creates too much load on the API server. So making sure that if you do lose that token, you don't lose everything. And then an interesting concept, this idea in security that you only want to deploy what you need, right? So your container should only have your executable in it and nothing else. That's great until you need to debug something. So there is a concept now called ephemeral containers where you can attach to a running container. So you can have a container with debug tools in it that you can attach to the running container and then use that to do your debugging. That's going to become easier to use. You're going to see a lot of that. That's going to make that really locked down container that doesn't have any tools in it a lot easier to implement. So what does it mean to build a secure image? It's really not that hard. It's really hard, but not that hard. It's a very basic checklist. If you do these things, you're like 99% of the way there. Do not use root. When you build your container, before you run command, it should have a user, and it doesn't matter who the user is, right? Just have a user. It doesn't have to be a user that exists on the underlying system. Assume no Linux user ID. So there are some things that need to know the Linux UID of the user, and there are some funny hacks around that, but for the most part, you shouldn't care. Only write to volumes. So if you need a scratch space to write stuff, write it to empty dir. That's what it's there for. Why do you not want to write directly to a volume? Because once that container goes away, you've now lost what you've written. So if somebody's doing something bad, like generating code or generating tokens or whatever inside your container, that's all ephemeral. If they're writing it to a local scratch space, you lose that container, it's gone. Whereas an empty dir it's on your disk. Like it's a physical space that can be backed up and monitored. It's just attached to the running pod. So now you have something that you can audit. You have something for forensic background on. Rebuild often. As often as you can, and automate that process. So if you're just generating containers and then you're letting them run for years on end, you're treating it like a VM. You don't want to do that. You also want to be able in constant motion. The more you're moving, the more you get used to moving. It's sort of like riding a bike. I taught my oldest son how to ride a bike using training wheels. It was a complete fiasco. I told my younger son, you're not getting training wheels. You're going to get a pedal bike. You're going to learn to go faster, quicker, and you'll be safer that way. Moving fast is much safer in the Kubernetes and cloud native world, constantly rebuilding. And keep an eye as to where your images are from. Not all images are the same. Don't just grab an image on Docker Hub and run with it. If they're kind enough to provide source for how they built the image, okay, I've done that. But don't just pull out random images. Be careful where you're getting it from. And then think about policies and contracts and boring stuff that becomes important, right? Because I'll give an example. I'm going to pick on Red Hat, and I love Red Hat. So I'm going to pick on them for a second. Red Hat sells Linux. So if you don't want your Linux distro to be Red Hat for whatever reason, you don't pay for Red Hat, people might ask really annoying questions about that UBI instance, which is totally legit. Like, you don't have to buy Linux, Red Hat for it, but they might start asking questions about it. Think about those things when you're considering what your distro is. And it might not really be a real security thing so much as a make your life easier thing. Yes? So would I recommend building images yourself? Potentially. It depends on the scenario. So if you are running a system that you manage internally, and let's say that internal system relies on a Tomcat instance, I would probably build that myself because there's no vendor I'm going to buy that from. Now, I'm a vendor. My company is a vendor. I'm a software vendor. My customers don't build their own instances of OpenUSINT. They could if they really wanted to, but that's what they pay me for, right? So as a vendor, I say, no, here are my gold images. This is what you want to use. So it's a good question. If you have a trusted source to get it, make your life easy. But yeah, if you don't have that trusted source, build it yourself. Yes?
Just one comment. I've seen situations where, I know you said you haven't done too much for Windows, but I know I've seen situations where with IIS, you do need some root. So you kind of have to bend a little bit with it in some instances, like with older .NETs, but it's few and far between.
Yeah, I mean, it's like English. Every rule is meant to be broken, right? I mean, flexibility is an important part of any policy set. So yes, there will be times you have to do it. Just be cognizant of the fact that they should be few, like you said, few and far between. And you know, how do you, like, I was actually dealing with this with a customer last week where the container had to run as root. And they said, okay, well, how do we do this securely? How you do it securely? You buy 2 more nodes and you make sure that those are the only things that run on those nodes. So there are ways to handle it if you do have to do it, but for the most part, you should be able to avoid it. Next buzzword bingo, SBOM, software bill of materials. This has become a big thing, especially for Log4j, since Log4j came out. And again, there's way too much to get into here. The big thing I just want to point out is you want to have one of these, whether it's an official version or not. I'm a Java developer. I've been writing Java for 20 years. This is not a new concept to anybody who's used Java for that long. Maven and Gradle does this for you. Although there's still plenty of projects that use Ant, which... But my point is that this is really important. Knowing what's running is super important. The direction to go in is storing it with your container. So OCI is the Open Container Initiative, is the standard for defining how containers get stored, because you know containers just a tarball of tarballs. How that gets stored in a registry. And it provides for storing additional metadata. So what we're now using that metadata for, signatures and SBOM. So you can say, all right, I'm going to generate my SBOM. I'm going to push it into my registry along with my container. I'm going to sign it. And now that is a nice little package for that when someone says, hey, what's running where? You have a place to look. There are different layers of SBOMs. You can have an SBOM for your source code. You can have an SBOM for your running container. They might look very different. So it's important to, again, automate. You try doing this manually, you are going to find yourself behind the 8 ball very, very fast. So this gets us into farm-to-table supply chain security. I really like SigStore, and not just because I have a couple of friends there that are really great people. I really like it because it changes the concept. We've been signing artifacts as long as we've had PKI. We're terrible at it. We are awful at it. We either lose the keys, we let stuff expire, and when stuff expires, we say, oh, just hit continue. Don't worry about it. Where cosign changes this and where SigStore changes this is based on your identity. So the certificate that you sign with is only good for 10 minutes. It's based on who you're logged in as or who your pipeline is logged in as. I do a hour and a half long workshop with my friends at SigStore on this. So this is a very complex topic on its own. The thing to take away from this is it doesn't matter about the keys, it's about the identity. Who did the signing? And that's what these different components are here for. SigStore is basically a CA with an API. Rekor tracks it. So you have an audit log that says when stuff happened. And because it's all signed, you can track it back. So that's the important thing about the farm-to-table supply chain security. It's never stopped an attack. I don't know that it ever will stop an attack, but it helps build confidence in knowing where things came from. So probably used a lot more in post-mortem than in stopping anything, to be honest. So in order to do that, you have to spend a lot of time with your infrastructure, because if the key doesn't matter anymore, it's the identity, then you have to have an infrastructure that protects that identity. So this is the lab that we do with SigStore. And so we got a lot going on here. We have an open unison that talks to Kubernetes. There's an Argo CD. So Argo CD is used for GitOps. That's synchronizing Git configurations from Git into your API server. That's got to talk to Kubernetes. We got a workflow that's running on GitHub. And we have a container registry. These things all have their own identities and can all be done ephemerally, so that when Argo talks to Kubernetes, it's using an ephemeral identity. When GitHub needs to push a container to Amazon, it does it with its own identity. I don't have some secret that's stored in the repo that's used every time. When Open Unison talks to GitHub, again, it's an ephemeral identity. It's not using an identity that's some static token that will never expire. So I don't expect you to be able to build it by the time we're done with this conversation. And I still managed to get it in by 3 o'clock. But you know, some of the main points that, you know, to come back to this, identity is your main focus in security when it comes to Kubernetes. That is the most important thing. That's not to say firewall rules and node security is not important, but as you get into the higher level constructs, the identity of your systems becomes far more important than any other single aspect of the system. And that's where you really need to spend your time. So I threw a ton of information at you, and now it's time for the test. No, just kidding. So where do you find this stuff online? Because, you know, I mean, this is going to be recorded, so that's good. If you want to learn about Open Unison, my humble project, available up there, all open source. You can find me on the Twitters or on the Mastodons, whichever one tickles your fancy. And everything we do is open source, so go ahead and find that there. If you want to talk to me, reach out to me via any of these mediums, or I am also on Slack for Kubernetes. Feel free to just ask a question about OIDC or RBAC or in SigAuth, and I will probably be one of the people who answers you.